Have you ever wondered why a rubber ball bounces back after hitting the ground? It's not just a simple trick of physics. It's a fascinating interplay of forces and material properties that make it possible, or how a sculptor can mold clay into different shapes. The clay's unique properties allow it to be shaped and reshaped, creating beautiful and intricate designs. What about the strength of a skyscraper, standing tall against the wind? These towering structures are engineered to withstand natural forces, thanks to the materials used in their construction. The answer lies in the fascinating properties of materials: elasticity, plasticity, and rigidity. Each of these properties plays a crucial role in how materials respond to different forces and conditions. These properties determine how materials behave under force. Scientists and engineers test these properties to understand and predict material behavior in various applications. Some materials are stretchy and bouncy, returning to their original shape like a rubber band. This elasticity is what makes them ideal for products that need to absorb impact and return to form. Others are moldable and change shape permanently, like clay being molded into a pot. This plasticity allows artists and craftsmen to create lasting works of art and functional items. And then we have materials that are super strong and resist bending or deformation, like the steel beams used in construction. These rigid materials provide the backbone for our buildings and infrastructure. Understanding these properties is key to understanding how the world around us works. From the clothes we wear to the buildings we live in, material properties influence every aspect of our daily lives. It's the reason we can build bridges that span rivers, design airplanes that soar through the sky, and even create comfortable clothes that move with our bodies. Each application relies on the unique properties of different materials. So get ready to explore the amazing world of material properties with me. We'll dive deep into the science behind these properties and see how they are applied in real-world scenarios. We're about to unlock the secrets of elasticity, plasticity, and rigidity, and discover how these properties shape our world. Join me on this journey to understand the materials that make up our universe. Let's start with elasticity, the property that makes things stretchy and bouncy. It's a fascinating characteristic that we encounter in our daily lives more often than we realize. When you stretch a rubber band, it's elasticity at work. This simple action demonstrates a complex physical property. The rubber band wants to return to its original shape. This is because the material is designed to resist deformation and snap back. The same goes for a spring being compressed or a trampoline being stretched. These objects store energy when deformed and release it when returning to their original state. Elasticity is all about a material's ability to deform under stress and then return to its original shape when the stress is removed. This ability is crucial for many applications. Think of it like a magic trick, but instead of a disappearing rabbit, it's all about disappearing deformations. The material seems to have a memory of its original form. Rubber bands, springs, and even certain fabrics are examples of elastic materials. They all share this remarkable property. They can be stretched, compressed, or bent, and they'll bounce back to their original shape once the force is gone. This resilience is what makes them so versatile. This property is what makes them so useful in everyday objects. From simple office supplies to complex machinery, elasticity plays a vital role. Without elasticity, we wouldn't have things like bouncy balls, comfortable shoes, or even working engines. It's essential for both fun and functionality. It's a fundamental property that makes our world a more fun and functional place. Elasticity is truly a cornerstone of both play and practicality in our lives. Now, let's talk about plasticity, the property that allows materials to be molded and reshaped. Imagine molding clay with your hands. You're using force to change its shape permanently. That's plasticity in action. Unlike elastic materials that bounce back, plastic materials remember the change in shape. Think of it like this. If elasticity is about temporary change, plasticity is about permanent transformation. Clay is a classic example of a plastic material, but there are many others, including certain metals, plastics, and even some types of glass. The ability to mold and shape these materials is what allows us to create a wide variety of objects, from car parts to delicate sculptures. Plasticity is a powerful property that allows us to shape the world around us. It's the reason we can turn raw materials into intricate designs and build structures that meet our specific needs. Finally, let's explore rigidity, the property that makes materials resist bending or deformation. Rigidity is a crucial characteristic in the world of construction and engineering. Without it, many of the structures we take for granted would simply not exist. Think of a steel beam holding up a bridge, or a diamond maintaining its shape under immense pressure. These materials are designed to withstand significant forces without changing shape. That's rigidity in action. Rigid materials are the strong and silent types of the material world. They provide the necessary support and stability to various structures, ensuring they remain intact and functional. They don't like to change their shape, and they put up a good fight against any force trying to bend or break them. This resistance to deformation is what makes them so valuable in construction and other applications. Steel, diamond, concrete, and even wood are examples of rigid materials. Each of these materials has unique properties that make them suitable for different uses, but they all share the common trait of rigidity. They're used in construction, engineering, and countless other applications where strength and stability are essential. From the tallest skyscrapers to the simplest homes, rigid materials are a fundamental part of our built environment. Imagine trying to build a house with jelly instead of wood. It just wouldn't work. The rigidity of wood provides the necessary support to keep the structure standing. Rigidity is the backbone of many structures we rely on every day. Without it, our buildings, bridges, and other constructions would not be able to withstand the forces they encounter. It's the property that allows us to build strong and durable structures that can withstand the test of time and the forces of nature. Rigidity ensures that these structures remain safe and reliable for years to come.